Okay, so I'll be going over reflection. It's a very easy topic in waves, which many students overlook, and I realize that some students don't even feel easy questions on this reflection topic. So I'm just going to go over it quickly. So if I have a plane surface, right, and then you have an incident ray. So law of reflection states that the angle of incidence and the angle of reflection is going to be equal. I'm going to use a broken line which makes an angle of 90 degrees with this surface to represent the normal. So this is normal, and it's occurs at the point where the incident ray strikes the surface and the reflected ray is made. So I'll call this angle here the angle of incidence, and then this other angle the angle of reflection. Now law of reflection says that what these two angles are equal, so I is equals to what r when we are dealing with what reflection. So I is equals to r. Now there's something called glancing angle. So glancing angle is this angle which the rays make with the surface. So this angle is what we call glancing angle. And as you can see from geometry, if the normal at a point makes an angle of 90 degrees, then glancing angle should be equals to what? 90 minus r, or 90 minus I, right? So glancing angle is equals to 90 minus r, or 90 minus I, because I is equals to r, right? So if you are given glancing angle in the question, you want to get your angle of incidence or angle of reflection, all you have to just do is what? Just say angle of reflection is equals to 90 minus what? The glancing angle. I've got your answer. And there's one more parameter I need you to take note of, which is the angle of deviation. So angle of deviation is the angle between what? The angle the reflected ray makes with the axis of the incident ray on the other side. So I'm going to just trace a broken line here just to represent the continuation of the incident ray if it was not deflected. So this is what we call the angle of deviation. This angle here is called the angle of deviation, and represented by the letter D. So what is angle of deviation? I'm just going to tell you the formula straight away. This D is given by 180 minus 2r, or 2i. You know r and I, they are equal when it comes to reflection. But how do I arrive here? Simple geometry. Now if you look at the angle of incidence, you look at this angle and this angle, they are vertically opposite angle. Therefore if this is angle I, this part will be what? Angle I as well. Now for this part of the angle, if this is angle I, then since from here to here is 90 degrees, this place will be 90 minus I as well. Alright, and what's left? This is the glancing angle, and the glancing angle is given by what? 90 minus I, or 90 minus r. So you see that the angle, the angles that form the angle of deviation is actually 90 minus I and what? 90 minus I put together. So angle of deviation is equals to what? 90 minus I plus the glancing angle, which is also what? 90 minus r, which is same thing as 90 minus I. So I'm not going to write 90 minus I there. So if you add this together, you find that you will get 90 plus 90 is 180, and then minus I plus minus I, same as minus I, which is equals to minus 2I. That's the formula for angle of deviation. So that's the easy part. If you have to calculate on any of these terms, I'm sure you're able to do it seamlessly. Alright, so let's talk about mirror rotation. Now, if the reflective surface or the mirror is rotated through an angle, there is a law that states that if it's rotated through an angle, then the reflected ray is rotated through twice that angle. So if we rotate, let's assume this is a mirror, right? And then we rotate this mirror. I'm going to use a broken line to show we rotated the mirror. So we rotate this mirror through an angle theta. The reflected ray is going to rotate through an angle 2 theta, and that's what the law states. So initially, let's say this was the reflected ray. So a ray was incident here, and then obviously, but then we rotated the mirror. So now the new angle of the reflected ray, or where the reflected ray is going to rotate through, is going to be twice that angle, which is going to 2 theta. Now don't worry about the proof for this, just remember that if you rotate the mirror through an angle theta, then the reflected ray is going to rotate through twice that angle. You're going to use to solve some questions as well. So next I want to talk about is images formed by two mirrors at an angle. It's a very easy formula. So if you have two mirrors inclined at an angle, then the number of images formed by those mirrors is given by the formula n is equals to 360 over theta minus 1. So in your exam, they tell you two mirrors are placed at an angle of 60 degrees to each other. How many images will this mirror form? It's simple. You just put that your formula 360 over 60 over 60. This should give you what? 6, right? Minus 1. Don't forget the minus 1. So minus 1 is equals to 5 images. This is easy mark in JAM.